I like to welcome everyone here because this time slot is for myself as a listener is quite painful. I would like to not keep the panel and presentation too long and get to the point of it. As you know, this panel is about smart robotic technology and smart systems in medicine. I myself am a physician or doctor, and also I'm a surgeon. I'm not really a representative of the smart side of the panel. I don't really know much about that. But on the medicine side, do we have any students of medicine here? It seems like 3 people are here. Yeah, most people in the medicine fields are not very enthusiastic about the smart aspect of this panel. Most of them really don't care about it, they don't feel like it, or they don't really have the energy for it. But because I'm a surgeon, I've seen because of the sanctions we've experienced, we don't really see a lot of imports of robotics in surgeon also, or any robotic technologies in surgery due to different reasons. Sometimes they don't have the money for it. We can't make it internally. Maybe sometimes it's prohibited. Maybe sometimes sanctions are stopping it, and there's a variety of reasons. I would also like to begin with the name of God. Hello everyone, I am Ali Ghorbandaei, master's graduate of Mechatronics, and also in the research, active in the research center in the robotic research center in Sharif University. In the name of God, I am Morteza Ahmadi, doctorate student of mechanical engineering from Sharif University, and I am as of right now, active in social robotics, a research center in Sharif University. I would like to say hi to every attendee. I am Mohammad Ahmadi, Chief Executive of Mono Afzar, and also free VR house startups, and also Biopulse. I am here at your service. Hi. I'd like to say hi to everyone here, dear friends as well. I am Mohammad Sharifi, Chief Executive of Department of Innovation and Technology in the International Room of Commerce in Iran. If you all agree, let's cut to the chase and have a definition of what social robotics is, and then we'll go on from there. There seems to be a problem with the audio capturing. Nothing is being captured. Well, I'd like to give a quick explanation on social robotics and how it can be, how can it be used for us, and how can it be used in medicine, fields like medicine. Social robots are agents or smart agents that can interact within the confines that have been predetermined, can interact with other physical agents or smart agents. So that's not necessarily interactions with humans. They can interact with other robots and other physical things. which can itself bring about another field of research, robot-to-robot communication. As you can see in the timeline on the screen, you can see how we've seen a growth in recent years in this type of agent and this type of robots. And the most common application we've had for these robots is in rehabilitation and also helping nurses with their activities. So had an increase of the role in education and also as entertainment. They have been always there. We've seen them as kind of robotic pets. And these days, considering how AI and LLMs have developed, they are able to convey messages and convey information to humans. They can be a force or an informant in many systems. They can be also used in marketing and branding as a way to sell products because of their charismatic nature. As you can see, we've got a list of social robotics that we have developed in Sharif University. Some of them I will introduce to you, and some of the others are going to be introduced from my friends like Mr. Mohammad. And let's go on quick to talk about what made us get us into this field. So all of these started with the purchase of now because we couldn't really accept the risk of developing these robots on our own, and we wanted to do a visibility study. We studied and we used now robots. We used it in different scenarios. We tested it in the scenario as a sick child, as a nurse, as a rehabilitated person, and we've also tested it as people of different backgrounds who interact with children with cancer. It would go to those places, these centers who hold cancerous children. It would interact with them. And the results of that study, it came to that these interactions led to reduced stress in cancerous children. It had an increase or a positive effect on their education. They would accept what they're told, what they would have been told sooner and better. And overall, there was a tangible positive effect on their studies, their education, and also their rehabilitation. And there would be a better emphatic relationship between the robots and the children because they would not be ordering them around. And this seems to be a problem. 50 slides. This seems to be a problem with the slides. They're asking questions. After the research on now robots and also social robotics and also children and the research on their application with cancerous children, we did some research on kids who have autism and these robots applications in their education, learning or teaching music or other types of things. And based on the questionnaires we've done after the fact, the severity of the autism in these children have decreased seemingly, and that was what led us to conclude that yes, we can and we should develop these robotics internally in our country. This is something that's actually part of my doctorate thesis and dissertation. It was about using robots with a silicon face or with a face mimicking humans to mimic different kinds of facial expressions in mirrors to use in education of children in different applications. It had different applications. It was published in the Social Robotics International Journal as well in 2018. So yeah, that was the beginning point of developing these robots internally and in Iran. It all started with Arash, the robot that we thought would do the same things that Noah did, but this time using design language that we thought would be appropriate for appearing in hospitals with children. It got the final design that we landed on went through a number of phases of selection and voting. At the end of it, the robot named Arash was born. But the naming, or the reason for the naming, was unfortunately one of the relatives and friends of associates of mine was lost to cancer during the development of the robot, so that was why we named it. As you can see a sped up version of the video of assembling the first Arash that we developed. It was built for specifically for children and their age. I am waiting to reach the final shape of the final version of Arash, so we can go to the next slide. As you can see, the robot is being developed and assembled actually. This, as you can see, Mr. Sorapur, Dr. Ghaidari, who's part of the core professors in robotics in Sharif University, and also he's part of the Academy of Persian Sciences, and he was the executive officer and manager of this development, and we also, after Arash, we actually developed Arash 2. We made some tweaks, and also it was a semi-industrial robot. We made some tweaks based on the feedback we got. Well, this robot, comparing to its own predecessor, it had better sensors, it had stand or mapping capabilities. These are tools that help the robot to interact with people without hitting objects, without seeming awkward in places. It could be interacting better, and it would be more natural seeming. This robot also presented a few events. It came on stage as a presenter, but its main applications, it was designed for educational purposes and in fields of medicine. This robot from University of Sharif. And after that, two things happened. We unfortunately had an increase of the exchange rate, and it would cost it too much to develop new robots, and we also felt the pet-like or animal-like robotics, we lacked the presence, or we felt the lack of presence of them, because these robots are very useful for interacting with children. There were a few designs going around at that time, and after all that, the robot called Feel or Elephant was approved, and the main application we saw is interacting with children, or it actually acting as a children, for children to teach the robot about their condition, for them to be more ready to face whatever they need to face. And because of new developments we've had in different algorithms and the emergence of better AI systems, these robots, beside their routine applications, they might be fit to be equipped with equipment that can make them eligible for more cognitive knowledge, or cognitive knowledgeable activities, and they wouldn't need someone controlling them. They would be they wouldn't need control from another operative. They could actually act as an agent on their own and give responses that are not repetitive, because if they do give repetitive answers to the questions, children might find out that this is not as smart, as smart as it seems. That would shatter the veneer and the illusion. I would like to give the rest of the things that I need to do to Morteza. The presentation is taken over by Morteza. Mr. Ghorbandaei has a problem. Most of your demographic, your target demographic in these robotic industries are for children, or is children. Can we move or pivot towards these robots to be used in teaching adults? For myself, when I was doing my residency, as it is in Iran, I was learning on real human beings. I was practicing on those, and if I were ever to make mistakes, I would be doing it on a real human being. Is there any way to do it on robots? Yes, there are some answers, but they're not in the social robotics category. For example, for the surgery called laparoscopy, there are robots that simulate the environment of a surgery for surgeons to practice and get ready for whatever they need to get ready, and they will be practicing on those robots. Another question I have is, people who work in AI, or people who are not very familiar with AI and technology, they really believe that these robotics who are helping nurses or helping other individuals in the hospital are there to replace those individuals and personnel. From what we're observing now, right now, that possibility is not there. As of right now, they're helpers of the personnel, nurses and such. They're not really made to remove anyone from the from the hospital and from their work. It's just like other equipments that we've had who had changed, like sharp objects that you need, scissors that you need, these kind of things. These are the same as robotics. The robotics are just a new tool that is being introduced for treating different ailments. One of the examples I gave was autism, or dealing with children who have terminal diseases. Mr. Ghorbandaei needs start one of my criticisms that I have for Iran's field of medicine. Whenever you see posters or informative material for these kind of fields, medical fields, you never see anyone who's actually involved with patients, like a doctor or nurse, and credited. They're not really there. They're not really the writers of these material, and that's an unfortunate thing, because mostly people who are active in these fields, like yourself, are engineers, and we don't really have this connection that we need between doctors and engineers. I would like to say something here as well. When I was working with children with autism and testing on those, we've had two psychology experts and therapists, cognitive therapists, and they were present for every intervention session we had. Mr. Ahmadi starts to talk. We in Biopulse are using AI to estimate people's pulses. It would be we use PPG, which is a signal that can estimate a person's pulse with a picture even, or signals we call BPP. It is a case of AI training to do this. And yes, in this project we are working directly with Sharifi University, with professors and everyone in fields of like medicine. The whole credibility of a project comes through the medical experts, not really the engineers themselves. The surgeon starts speaking. I myself have had an idea, and I've been going to universities as a professor as well. I've been going to universities to find a team. Me as a doctor, I'm most of a curator of ideas. I'm not really experienced in engineering fields. I can only operate as a translator between the medical language that we have, let's say, to the engineering language. But unfortunately, the things we see in here, most students, whether it be engineering students or medical students, they're really looking for projects that work or reach a conclusion in a month. And so because of that, there are not really good teams that you can find for these kind of things. I wish there would be a place for these two forces or these two kinds of teams to come together and work together. That would be something I really would appreciate. Well, what you said, I believe the most useful projects and the most impressive ones that come from our country are ones that have done or have operated under that cooperation, which you specifically pointed out. Like with the example of the surgeon robot, we've had Sina, It was like a bridge between two fields of engineering and also medicine. It was a collaborative effort between some professors from University of Tehran and Shahid Rajai with some other engineering professors. And as my friend mentioned, these uh, projects that are have a clear effect on uh, the greater public. Yes, the number of them is quite low, maybe because we don't really like having strangers and having other people active in our fields. But I believe there is a good number of these projects and a group number of teams who work uh, side to side by each other, like others, even like people who are active in software engineering or even in fields like education. We have teams that work very cooperatively together as of right now, even in Tehran. If you go around and you can see them, actually, you can observe them. There seems to be a problem with capturing, and they're changing presenters. Well, I won't take too much of your time. Um, Let me talk about another side of social robots and cognitive social robots. The word cognitive robots together, cognitive and robots. The more cognitive aspect of it is in places that we need robots to interact or we use them to interact with people. Interacting with people can have a variety of different modes. This could be emotional, this interaction. Let me just say this. When we talk about robots, people generally think of something that's been that looks like a human necessarily, and it's engineered to do like that. But in our definition, a robot is anything that can feel and talk and interact. There's no specific requirements for their appearance. So in this interaction could be emotional, just to say a good night for a child at nighttime and talk to them when they need to. This could also be any type of communication. The necessary thing is to show the audience something, a message. Our interactions could be semi-automatic or automatic. Semi-automatic, like Wizard of Oz, it would have an operator behind them, but automatic, fully automatic, there would not be any operator. We're not really replacing any humans. They're working side by side with humans. Like for an example, if we need a teacher to bring a robot to the classroom, there wouldn't be any operator behind the robot to operate it. That's what it's removing. So the word cognitive that we use ties these projects to three fields. We need experts from all three fields to develop a good project. Naturally, the first one is robotics, and the other field is AI, artificial intelligence. We use people who are experts in software engineering and also cognitive research and also biology experts. An important question we need to ask is these things you mentioned have been gone through or have been done for years, and there hasn't been anyone complaining. So why do we need, or why would we need robots? Well, the answer I gave is for activities and services that need a great deal of patience, robots can really help humans, because at some point a human might get angry. If I'm teaching something, I might at some point get angry. The charisma and the influence of robots is greater than humans, as you might have rather a robot to present for you rather than me. It would have been more attractive, it would have been more better, and obviously would have been more impactful. There wouldn't be so many mistakes and stuff like that, and it would be accepted more widespread. And I've done research on this. For mostly children and everyone, they would rather, or they would better listen to people who are not, or not people. They would listen to them better. But these cognitive robots, we don't really limit them to traditional definitions of cognitive helping or just helping. We just really define it as helping your peers, helping anyone. We use these robots to meet specific needs. As an example, let's say being deaf or having difficulties hearing. Their only way of communication with the outside world is sign language, specifically the Iranian sign language that we have. Whatever we do, our activities are limited to people who have a difficulty speaking or communicating with the outside world. And also dyslexia, which has been officially recognized as a disorder, and it is not a child being a child per se. When they're reading something, they're really having difficulty reading that. Naturally, working with these two people and these two individuals, after a certain point, it's going to be very difficult, and they need more patience, and that's a great help. Having robots with you, that's a great help. As you can see on the screen, we have Rasa robot, which has been specifically designed to teach sign language, which was developed in Sharif University as well. As you can see, every finger the robot has is able to move, and the monitor you see on the robot's face can mouth the words. Let me just say this. Iranian sign language, unlike any other sign language in the world, actually utilize both hand gestures and also mouth gestures, and also that's something they can differentiate or be meaning differentiating, which is something we included in the robot. This robot does not have legs. It can move around with wheels. Using a special glove compartment could imitate the students' movements as well, and it could be offline or online or in a number of ways, and it has a number of applications. We've tested this. This seems to be a problem, but we tested this a lot, and it has been very impactful in teaching the sign language, whether it be to children or adults. This was something that needed cooperation with experts, we really needed to interact with them, and we had to learn sign language ourselves. What we're really proud of is the invention of this robot actually led to university for the deaf piece to be established, and the name of it is Farishte University, Farishte Azad University. And the robot can learn new algorithms and use those. The robot we use in treating dyslexia is called Taban. It's a doll-like robot. It has technologies and capabilities of facial recognition and also voice recognition. And due to recent developments in AI, this capability has been added to it to reach conclusion, make decisions fully automatically and fully on its own. All the things we've talked about, all of these can be used as an avatar, not with any physical shape, using VR goggles. And now let's move on to the three items or the three words that we really heard about. Let's just define them. LLMs, who are like ChatGPT, DeepSeek, we call them large language models. And then we have agentic AI, which can really someone who's not very object that is not human, and make them look like human. And then we'll have common sense reasoning that lets a robot operate without predetermined principles, and they themselves can reach conclusions and make logical dissertations. All of these can reach to better communication, obviously, and also customizing teachings and other things as well. Thank you all for listening. Well, thank you for your speech. The doctor, they have started speaking. Mr. Ahmadi, because you have medical equipment startup, can you just tell me, in your opinion, robotics can be useful in education as well? Well, just like my friends mentioned, they're more active in those fields. I'm mostly active in the equipment and hardware aspects, or sometimes even software. Things we do are like added reality or virtual reality. It's very apparent to me. Education that takes place is mostly takes place through simulation. For example, we simulate the anatomy of a body, and then we put it into an AR machine, and when somebody, like a student, uses these or wants to see a scan of a physical anatomy, this AI can, for example, give them dissertations or explain everything to them in detail. As an example, a study or something we've done with a university in Dubai was that we just simulated the anatomy of a person in AI, and that would itself teach other students in great detail the things and these things you need to learn in relating to each part of the body. And something that is very useful to us is getting feedback. On the same time, we could look at how much the learner has learned, and we can get instant feedback from them, and it's very tangible and very there is also the metric of the longevity of it and how long did that stay in the learner's mind. From gaze detection and also heat mapping the gazes and the look of the learner, we can also assert how much they learn from it. We can use this in different apps, and also we can use it in the analysis of the data. When the amount of data increases, most people are not really able to do that, and able to analyze them to that degree, to a suitable degree. But when we have AI, it can be trained to do that, like ourselves, like we did in the blood pressure. We train a model with the data we've gathered in the medical fields. Sometimes there is a need to do a bit of fine tuning, but with these models that we can provide based on medical data, these are things that can greatly help people learn. For me, the doctor start. For me, as someone who's just started and has graduated from these, for me, who I'm not very aware of these things, these kind of things are very appropriate and very useful for me. Even today, when I ask my students some questions, it's very fast, the response that they give with AI. Yes, they use AI to give responses like that. And as a last question, let me ask, we'll see, the whole medical field in the world, or global medical field, is going towards these things, using AI and using robotics. What do you think about this? Well, if I were to give my own opinion and why, we have to assert why the global industry is important, and why medicine itself is important. Well, medicine is one of the more costlier parts of an economy, and it has a direct link to social justice, security, and other important metrics of our economy and society. Another thing I like to say, that health and medicine is the future's capital, let's say. It's a resource for the future. Something that research has also backed up is the trend that we're seeing, the cost of global medicine, the cost of it, the trend that we're seeing is on the rise. The cost is on the rise. The trend is so large that the increase that we've seen is larger than the GDP of some countries. This number, I believe, is close to $10 trillion, which was admittedly close to Corona and also quarantine. But what I want to say, it has a lot of value, and it is costly to everyone. Let's get back to why these things are actually quite helpful. These things that we've been talking about. As an example, let me say life expectancy and the GDP, that is directly related to their health metrics, the health metrics that they use to assert themselves. In America is an example of a high percentage of GDP that is spent on medicine, and by average, people, each person spends about like $12,000 on health, and the difference is quite large. I believe in Pakistan it is 50, and it has proved that even though you're spending a lot of money on your health, you might not be getting as much, you might not be as healthy as you thought compared to how much you're spending. Harvard University actually did a study on this. They are redefining medicine with these tools. If a country like USA, who spends a lot of money on their health departments and medicine, if they use these tools, they would actually save up to 10% and that itself could greatly help the American economy and their GDP. It would from each person, for each person, you could actually save up to $300, which is a great deal of help on the GPT. Thank you for your comments. Let's wrap it up and reach a conclusion. This whole process of smarting, smart equipment, and also AI could actually save and help everyone involved, and it would save up capital. That was my conclusion. It would save money and also help the people involved. Thank you. I've talked a lot. Would rather everyone here to have an opportunity to talk as well. This seems to be a problem with the audio capturing. Well, I believe something that we've seen not seen a lot in Iran, in medicine, in public medicine, in the greater public's medicine, the effect AI can have here. Let me just have a short explanation on what I want to say. What we're doing specifically in Iran is blood pressure. We have 25 million people with a high percentage of blood pressure. We call them hypertension. Approximately 40% of them are not very aware, or not even aware what we have, that they have this condition. And only 10% of people have the device that's needed for taking the blood pressure. And every year around $300 million are spent from our GPD for this condition alone. And I'm asking everyone to pay attention. If everyone if you can work in AI fields and also in fields of medicine, we have a lot of place in the market. Because the things that AI has unlocked, the doors it has unlocked, it allows us to justly offer services to everyone across the board. We could offer services to people who are living in secluded places, who don't have access to available or access to good medical care, and that can they can know their blood pressure. These preemptive things, these preemptive assertions can help to save costs, save a lot of costs that are people having in the greater public. Thank you for your attention. Thank you for listening. Goodbye.